Before going to discuss about these two, let us discuss about the polarity. Polarity is nothing but the North Pole and South Pole itself, pole which have got its own entity, that is nature. Covalent bonding as an electron sharing. The electrons in a covalent bond are always shared equally by two bonded atoms. A covalent bond that has an equal sharing of electrons. For example, in the hydrogen molecule, this is a hydrogen molecule. This hydrogen molecule consists of two hydrogen atoms. Each hydrogen atom has got only one electron. So there are two hydrogen atoms and hence two electrons. These two electrons are sharing each other, mutually sharing each other. So here, equal sharing of electrons. Hydrogen has got one electron, this hydrogen has got one electron, equal sharing. This equal sharing of electrons leads to the formation of non-polar covalent bond. Now, because they are equal sharing of electrons. So therefore, coming to the polar covalent bonds, polarity is different. Here polarity is same. Here polarity is different. Why it is different? Observe the figure carefully. The hydrogen and fluorine molecule. This is here two different atoms. Covalent bonding as electron sharing. The electron in a covalent bond are not always shared equally by the two bonded atoms. Unless the bond connects two atoms of the same element, there will always be one atom and attracts the electrons in the bond more strongly than the other atom does, as shown in the figure, there in this figure. But here in the figure B, imbalance occurs there. There is a resulting buildup of some negative charge called negative here. Imbalance. This imbalance, unequal sharing of electrons, imbalance will be developed. One is partial negative charge, another is partial positive charge. Partial negative charge can be designated as delta minus, a small negative charge, and a positive charge designated as delta plus, a small positive charge is called delta plus, that is designated as delta plus on the other side of the bond. A covalent bond that has an unequal sharing of electrons, as in figure B, is called polar covalent bond. So you should be clear that polarity differs. Non-polar covalent bond is equal sharing, but polar covalent bond is unequal sharing of two different atoms. See here, equal sharing of electrons, non-polar covalent bond, unequal sharing of electron, delta plus, delta minus, that is polar covalent. In case of ionic bond, no sharing of electrons in bond. Instead of that, transferring of electrons. That we have already discussed in our previous classes. Coming to this bond type and molecules, water molecule, polar covalent, delta plus and delta minus. Oxygen has got delta minus and hydrogen is delta plus. Molecular shape, this is the molecular shape. Bond angle, it is a bent, bond angle is here bent. Molecular type is polar. Coming to the methane, it is a non-polar covalent. Carbon to hydrogen, carbon atom and hydrogen atom, and hence tetrahedral. This is a non-polar. In case of carbon dioxide, polar covalent, this is linear, non-polar. Electronegativity of oxygen. You see, there is a sort of A covalent bond that has an unequal sharing of electrons, as in the figure, is called a polar covalent bond. See, unequal sharing of electrons. Here, this is hydrogen. Hydrogen is a different atom. Oxygen is a different atom. So, and hence unequal sharing between oxygen and hydrogen leads to the formation of polar covalent bond. Electronegativity of oxygen is 3.5. Electronegativity of hydrogen is 2.1. See, quite different, unequal. Even electronegativity is unequal, and hence density, electron density is also different. Oxygen has got its own electron density, and hydrogen is having its own density, electron density, and hence the covalent bond that has an unequal sharing of electrons leads to the polar covalent bond. In polar covalent bond, such as that between hydrogen and oxygen atoms, the electrons are not transferred from one atom to another. Instead, some outer electrons merely spend more time in vicinity of the other atom. The effect of the orbital distortion is to induce regional net charges that hold the atom together, such as in water molecules. You see, this is the water molecule, oxygen and two hydrogen atoms. This is a partial hydrogen and oxygen bond. Here, hydrogen and oxygen. Here, this is the chemical reaction. Then polar covalent bond establishes. Polar covalent bond. That means H plus ion. This here, hydrogen and hydrogen has got a partial charge, delta plus, and oxygen, delta minus. This is the covalent bond forms between two hydrogen atoms and one oxygen atom to form water molecule. Shared electron pairs have blue stars here. The paired electrons here. So there are fewer free electrons on this end of the hydrogen water molecule. As a result, this is the positive pole. This is delta plus is a positive pole and delta minus is a negative pole in case of water molecule. Nonpolarity. Electronegativity of iodine is 2.5. Electron density is equally spread out. So therefore, in non-polarity or non-polar covalent bond, there will be equal sharing of electrons of both this iodine atom. This is iodine atom. The iodine atom and iodine atom sharing mutually equally sharing of two electrons leads to the study of non-polar covalent compounds or bonds. A covalent bond that has an equal sharing of an electron, as shown in the figure, a non-polar covalent bond. Next, dipole moments can cancel each other out. A dipole moment, you see, dipole is delta minus and delta minus, this is delta plus. So 3.5, this is carbon is 2.5 and oxygen is 3.5, the non-polar equal distribution of electron density. As a result of equal distribution of electrons, the dipole moments can cancel each other and establish a carbon dioxide molecule which is non-polar in nature. Coming to the important non-polar substances are oils, fats, and waxes and other organic compounds. Here hydrogen, methane for example is a non-polar molecule. The electrons are distributed equally throughout the molecule. This means there is no positive and negative pole. Instead, the whole molecule has no net charge. As I told you, it cancels. Now carbon, water, ethylene and acetylene. Define covalent bond according to orbital concept. Covalent bond can be formed by the overlap of the orbitals belonging to the two atoms having opposite spins of electrons. So this is the opposite spins, electron from hydrogen and electron from carbon. Both the Carbon and hydrogen are quite different, and hence they are having a different spins, and hence the Lewis dot diagrams were an early attempt to describe chemical bonding and are still widely used today. This is very helpful for the Lewis dot style representations of chemical bonds or electron dot structure. Tetravalency of carbon. Carbon has got a tetravalent electronic configuration. 2, 4 is the electronic configuration. Carboatom can form 4 single covalent bonds. Example, methane. See